right, get ready to dive deep today because we're tackling a concept that's been, well, it's been a head-scratcher for physicists and philosophers, even mystics, for centuries, really.
Intriguing.
The ether. You guys asked for the ultimate deep dive on this. We're going to deliver. We're going from the big picture, like way zoomed out, down to the nitty-gritty details. We'll explore ether's history, its ups and downs, and even how it's kind of stuck around in modern science, which is
that's a good point.
Surprising. And hey, while you're here, if you're digging this, don't forget to like and subscribe so you can catch all our future deep dives. All right, now get ready because this is going to be mind-blowing. Ether, here we come.
What I find fascinating about the ether is, well, it represents this deep human desire, this need to find something fundamental, some kind of cosmic glue holding reality together.
So it's not just some like dusty old science idea. It's tied to like our basic instincts about how the universe even works.
Absolutely. And the idea has been around forever. Think ancient philosophers, right?
Oh, wow.
They were already wrestling with this idea of a fundamental substance, something that makes up the very fabric of existence. The ancient Greeks, for example.
Right.
They had this concept of ether, right?
Right.
A pure divine substance that filled the heavens, totally separate from like all the earthly stuff.
So it's not even just about explaining physics then. It's like a bigger question. It's about understanding our place in the cosmos.
Exactly. And as science evolved, as it does, right, the concept of ether kind of took on these new roles. In the 17th century, you've got René Descartes, famous philosopher, mathematician. He imagined the universe as a plenum. So a space totally packed with matter, just swirling around constantly.
Oh, wow.
These swirling vortices of ether, he thought they were responsible for everything.
Everything.
Yeah, motion of planets, transmission of light, the whole shebang.
Wait, vortices? Are we talking like tiny cosmic whirlpools here?
Yeah, precisely. Picture the universe as this massive interconnected ocean, and it's just full of swirling ether. Bold attempt, right, to make a unified picture of the cosmos.
Ambitious. I like it. But how do they square that with gravity then?
Yeah.
Which, seem to act over huge distances.
Oh, that's where Newton comes in.
Oh, of course, yeah.
Isaac Newton. He was skeptical of Descartes' contact action ether idea.
Okay.
He struggled with this notion. How could ether, right, transmit forces if it was just particles bumping into each other? So he proposed this, mind-boggling concept, action at a distance.
So you're telling me Newton, the gravity guy, thought it could act across empty space? Yeah. With no physical contact. That's wild.
It does seem counterintuitive, but yeah, that was his idea.
Okay.
Imagine holding two magnets.
Okay, yeah.
You can feel them attracting or repelling even without touching. Newton applied that same principle to gravity.
Okay, I get the analogy.
Yeah.
But was Newton totally against the ether idea then?
Not completely. He challenged that view, the contact action.
Yeah.
But he didn't rule out a more subtle ether, maybe made of particles. In his optics book, he has these queries, these open questions, and he suggests, maybe there's a more refined ether.
So he was open to it, but it had to be more, I guess, sophisticated than just particles bumping around.
Right. And this nuanced view, it paved the way for a whole bunch of new theories in the 18th century.
Oh, boy.
Seemed like everyone had an ether theory back then.
For everything.
Oh, yeah. To explain heat, electricity, magnetism, even chemical reactions, you name it.
Whoa, so ether was like the go-to explanation for any mystery in the universe.
You could say that.
They were drowning in ether theories.
And they ranged from, bizarre to surprisingly insightful. Like Herman Boerhaave, prominent Dutch physician, chemist, he saw fire as an ethereal substance, a kind of fiery ether. And then there's William Cullen, Scottish physician, developed this complex theory of chemical reactivity based on ether.
Wow. It sounds like they were trying to cram every phenomenon under the sun into this ether framework.
Yeah.
But did anyone push back against this ether obsession?
Yes. Amidst all the ether enthusiasm, you have this philosophical counter-movement, inductivism.
Inductivism.
It questioned theorizing about things you couldn't directly observe.
So if you can't, see it, touch it, measure it, you can't even talk about it scientifically. That seems like a pretty big problem for the whole ether idea.
Absolutely. Thinkers like Thomas Reid,
Okay.
Scottish philosopher, argued that, scientific knowledge should be based on solid, observable evidence, not speculation about unseen things.
Right.
But then you have figures like David Hartley,
Okay.
English physician and philosopher, and he thought, hey, we can still theorize about unseen things as long as the evidence is there.
So it was a battle between, like, seeing is believing and trust the evidence.
Exactly. And this was all happening against a backdrop of, well, new developments in physics. And they seemed to make ether even more plausible. Especially the wave theory of light was gaining ground.
Ooh, okay. Now you've got me interested.
Yeah.
What's the connection between light waves and ether?
Well, the wave theory of light, it proposed that light travels as waves.
Okay.
Similar to ripples, right, on a pond.
Right.
But if light's traveling in waves, what are they traveling through? Especially, in the vacuum of space.
Yeah.
The answer seemed to be ether.
Uh-huh. So ether was back in the game. It was what those light waves traveled through in the vast emptiness of space.
But how did they explain how light behaves then? Like diffraction, polarization, all that?
Well, that's where physicists like Augustin John Fresnel and Augustin Louis Cauchy come in. They developed these sophisticated mathematical models of ether to explain how light waves could do things like diffraction, where light bends around obstacles, and polarization, where the light waves vibrate in a specific direction. So they gave ether a math makeover to make it fit with light waves.
That's a big step forward. And then came James Clerk Maxwell.
Okay, Maxwell.
Who unified electricity, magnetism, and light into one grand theory, electromagnetism.
Wow.
Guess what he proposed as the medium for these electromagnetic waves?
Ether.
You got it, ether.
So Maxwell basically said, forget just light. Ether is the highway for everything electromagnetic. That must have been a huge deal.
It was a monumental discovery. He even calculated the speed of light based just on electromagnetic properties, reinforcing this idea that light was an electromagnetic wave traveling through the ether.
Ether was on a roll. Seemed like the foundation of physics. But I have a feeling this isn't the end of the story, is it?
You're right to be suspicious. The late 19th century saw the beginning of the end for the classical ether. Doubts started to creep in, fueled by experimental results that just didn't fit.
Uh-oh. Trouble in paradise for ether. What kind of experimental results are we talking about?
One of the most famous is the Michelson-Morley experiment. Conducted in 1887. The goal was to detect the ether wind.
Ether wind. Like, is that some kind of cosmic breeze blowing through space?
It's a good analogy. The idea was that as Earth moves through space, it should be plowing through this stationary ether, creating like a wind.
Right.
This ether wind theoretically should affect the speed of light, just like, a headwind or tailwind affects a plane.
So they were trying to measure how fast Earth was moving through this ether.
Exactly.
Makes sense. What did they find?
Nothing. They couldn't detect any ether wind at all.
Wait, no ether wind? That's like throwing a rock in a pond and not seeing any ripples. This must have been a big deal for the scientists back then.
It was a shock. Some tried to explain it away, saying, oh, maybe the ether is dragged along with Earth, or maybe matter shrinks in the direction of motion. But it was getting convoluted. No real evidence.
So ether was starting to lose its grip, and I'm guessing this is where Einstein enters the picture, ready to shake things up.
You got it. Einstein's theory of special relativity, published in 1905.
Oh, yeah.
Completely changed our understanding of space and time.
Okay.
And guess what? He got rid of the need for ether completely.
Einstein was like, who needs ether? Space and time are relative, and light travels through a vacuum just fine. Mic drop.
It was a paradigm shift for sure. His theory explained the Michelson-Morley results and other weird phenomena. No ether needed. The classical ether was, well, it was over.
So ether went from the bedrock of physics to being tossed out the window. That's a pretty dramatic fall.
It was a turning point, but the story of ether, well, it doesn't end there. Even with Einstein's revolutionary theories, the concept kept lingering in different forms, sometimes in the most unexpected places.
Ooh, intriguing. Before we get into ether's surprising persistence, though, let's take a moment to absorb all that.
I agree. That was a lot. I'm sure you've got thoughts brewing. We'll be back to continue this journey through the history ether in a bit.
Okay, we're back and ready to keep going with our ether deep dive. Before we took a break, we were talking about how Einstein's relativity basically dethroned ether, made it kind of irrelevant in modern physics.
Right, but the ether story, it's not that simple. Even as Einstein's ideas revolutionized physics, the ether kept well, kept popping up.
Like a ghost that just won't go away. So where did this ether ghost reappear?
One area was, attempts to unify electromagnetism and gravity.
Okay.
Remember Maxwell's theory brought together electricity, magnetism, and light all under electromagnetism.
Yeah, it was a huge breakthrough, showing those forces were connected.
Exactly. But gravity, well, it remained this outlier, didn't fit neatly into the picture. Some physicists, like Hermann Helmholtz, they tried to create theories to include both.
Okay.
And they often used some form of ether as this unifying medium.
So they were trying to bring gravity to the ether party, even though Einstein showed ether wasn't needed for electromagnetism or light.
Precisely. But these attempts, they ran into some problems. One was, how could matter, which interacts with gravity, move through this ether without any resistance? You'd think if space was filled with this stuff, it'd create drag on objects.
Yeah, good point. It's like trying to run through a pool of Jell-O. Gotta be some pushback.
Exactly. And another problem was explaining gravity's weakness.
Weakness.
Compared to other forces. Gravity's a weakling next to electromagnetism or the strong nuclear force.
Right, like a fridge magnet versus a bowling ball, no contest.
Exactly. This difference in strength, it puzzled physicists trying to make a unified theory with ether. But here's where it gets interesting. Even Einstein, who kind of kicked ether out with special relativity, later considered a new kind of ether in general relativity.
Hold on, didn't Einstein ditch ether? Why bring it back for general relativity?
It's a twist. Remember, special relativity describes space and time without gravity.
Right.
But when Einstein developed general relativity, explaining gravity as curved space-time, he realized, maybe ether isn't totally incompatible.
So general relativity opened the door to a new, maybe more abstract ether.
Exactly. Einstein's view on ether, it evolved. In a lecture in 1920, he even said, space without ether is unthinkable.
Wow.
But this ether, it wasn't that classical mechanical one. It was more abstract, not a material substance, but properties of space itself.
Okay, my brain's trying to picture this. Got an analogy to help.
Think of a magnetic field. You can't see or touch it, but it's real, influences particles. Einstein's abstract ether was kind of like that, a property of space itself explaining gravity.
So space itself has this invisible, texture that makes gravity work. That's wild.
A powerful way to think about it. But even though Einstein considered this, it never became central to his theory. General relativity became the main explanation for gravity.
So ether took a detour through general relativity, but ended up on a different path. Like it was searching for a place in physics.
Great way to put it. And ether's journey didn't stop there. It popped up in other areas, sometimes for philosophical or even mystical reasons.
Ooh, that's interesting. Tell me about those takes on ether.
Well, for instance, Ernst Mach, Austrian physicist and philosopher, he critiqued absolute space and time, argued our ideas about them come from our senses, not some fixed reality.
So he was saying space and time are relative to the observer. Sounds a bit like Einstein.
Exactly. Mach's ideas influenced Einstein. And Mach proposed this gravitational medium idea, a way to link an object's inertia to the matter in the universe.
Inertia, you mean like an object's resistance to being moved, like how a bowling ball is harder to push than a tennis ball.
Exactly. Mach thought inertia wasn't just in the object itself, but came from its interaction with all the other matter out there.
So a bowling ball's resistance comes from the whole sea of matter around it? Whoa.
It is a wild thought. And though he didn't use the word ether, his idea of a gravitational medium was similar. Einstein even called it Mach's principle, the idea that inertia comes from the distribution of matter.
So even though the old ether was fading, its influence led to these new ideas about matter and space being connected.
Precisely. And the ether story goes on. In the early 20th century, quantum mechanics, with its weirdness, brought even more chances for ether to come back.
Quantum mechanics, the world of tiny particles where things get bizarre, right? How does ether fit in there?
Well, quantum mechanics says particles act like waves and waves act like particles.
Right.
Uncertainty, probability, entanglement. It's a world where classical physics breaks down.
Yeah, I've heard in the quantum world, a cat can be alive and dead at the same time. Makes my head spin.
It's definitely different from classical physics. And as physicists learned about these quantum things, some wondered if a new kind of ether could explain them.
So maybe ether found a home in the quantum world. What role did they imagine for it?
One idea was ether could be the medium for quantum entanglement, this spooky action at a distance where two particles are linked and influence each other instantly, no matter how far apart.
Spooky action at a distance sounds like a sci-fi movie.
It does. And while this idea didn't really take off, most physicists explain entanglement without ether. It shows how ether keeps coming back.
It keeps popping up, even in unexpected parts of physics. But before we get too deep into the quantum stuff, I think we need another break.
I agree. Let's pause here and let you process everything. We'll be right back to finish up this amazing ether journey.
All right, we're back and ready to wrap up our epic ether exploration. It's amazing how this concept, something that seemed like it was just history, keeps coming back in new ways. It's like it's got a life of its own.
It really shows how powerful some scientific ideas are. Even when they're disproven, they leave this legacy that sparks new thinking. Ether, with its long and winding history, it's a perfect example.
Before the break, you mentioned ether's influence went beyond physics, shaped philosophy, spirituality, even pop culture. I'd love to hear about that.
Absolutely. Ether, with its mystery and the idea of it being everywhere, it really resonated with philosophical and spiritual ideas throughout history.
It seems like it gave people a way to think about reality, how everything's connected.
Exactly. Thinkers like Plato and Aristotle, they grappled with ether, saw it as a possible link between the material world and the divine. Even Newton, though he was skeptical of the mechanical ether, he thought about a subtler ether that could connect the universe in ways we don't understand.
So ether became a way to picture these unseen forces, the things that make the universe work and connect us all.
Yes, and its influence, you can see it in all sorts of esoteric and mystical traditions, alchemy, theosophy, things like that. In those traditions, ether is often this subtle realm of existence, a bridge between the physical and spiritual, a place where thoughts, intentions, they can become real. And the line between what we see and what we don't, it blurs.
That's fascinating how a scientific concept became something with such deep philosophical and spiritual meaning.
It shows how humans want to find meaning, connection in the universe, to look for explanations beyond just the material world. Ether, with this idea of it being everywhere, was a powerful metaphor for that.
And what about pop culture? I bet ether's been in tons of sci-fi stories.
Oh, you're absolutely right. Ether's been a sci-fi staple since the beginning. Writers like H.G. Wells, Jules Verne, Edgar Rice Burroughs, they all used ether in their stories, imagined it as a way to travel faster than light, or open portals to other dimensions, even the source of strange powers.
So ether became like a storytelling tool, a way to explain impossible things and take readers to these fantastical places.
Exactly. Think of that classic image, a spaceship flying through ether, leaving stardust behind it.
Yeah.
It's a powerful image, captures the wonder, the possibilities that ether represents.
Incredible how ether went from science to this cultural symbol of the mysterious, the infinite. But before we get lost in the ether imagination, let's come back to now. What have we learned about ether and what it leaves behind?
Well, one key takeaway is understanding that scientific knowledge, it's always changing. Something we think is absolutely true today can be overturned by new discoveries tomorrow. Ether, with its rise and fall and how it keeps coming back, it reminds us that science is dynamic, always evolving.
It reminds us that we're always learning, always trying to understand the universe better. What we think is true today might be totally different tomorrow.
Exactly. And another takeaway is how important it is to question what we assume, to be open to new ideas. Ether faced so many challenges, and it was often those challenges that led to the biggest scientific breakthroughs.
It's like ether, even in its failures, pushed science forward. Made us confront what we don't know, made us look for better explanations.
Precisely. And lastly, I think ether's story highlights how connected different fields of knowledge are. We've seen how it's woven through physics, philosophy, spirituality, pop culture, shows how science and imagination are linked.
It reminds us that knowledge isn't just these separate boxes. The most interesting insights come from where different ways of knowing come together.
Couldn't agree more. As we finish our ether deep dive, I want to leave you with this thought. If ether, which we thought was so fundamental, could change so much, what other things we think we know for sure might change in the future?
That's a great question. It reminds us that searching for knowledge is an adventure, and the universe is full of surprises. Who knows, maybe ether, in some new form, will keep shaping how we understand the cosmos.
The possibilities are endless. We just have to stay curious, keep our minds open.
Perfect way to end. So to all you knowledge seekers out there, keep questioning, keep exploring, keep diving deep into the universe's mysteries. And if you enjoyed this ether deep dive, don't forget to like and subscribe to catch all our future explorations.